Dear students, welcome to section 8 of chapter Relations and Functions. In the last section, we discussed how to find inverse of a function. Now for finding inverse, we have one more method by using composition of a function. So for that, first you have to know what is composition of a function. So composition of a function, first I will explain its definition. Let f from a to B and g from B to C are two functions, then there exists a function from A to C. That function is denoted by g of f. G of f. It's not g of f. Like that you have to read. Let f from A to B and g from B to C are two functions. Then there exists a function g of f from A to C, defined as g of f of x is equal to g of f of x, defined as g of f of x equal to g of f of x. This is just a notation only. This one is its definition, g of f of x. So I will explain by using arrow diagram, then you will understand clearly. We have three sets. Okay. A, B and C. Suppose elements of A, generally we can take as x. And f is a function from A to B and g is a function from B to C. Since x is an element of A and f is a function from A to B, what about f of x? F of x means image of x. Image of x will be in B. So element of B we can take as f of x, or f of x is an element of B. Since g is a function from B to C, image of f of x will be in C. Right? Now what about image of f of x? Will be g of f of x. Right? So x is related to element of C like this. Image of x is f of x and image of f of x is g of f of x. So element of A and element of C are related. That relation is denoted by g of f. That function is denoted by g of f and it is defined as g of f of x. G of f of x equal to g of f of x. I think now you understand the concept. So if f is a function from A to B and g is a function from B to C, then always there exists a function from A to C. That is denoted by g of f and which is defined like this. G of f of x equal to g of f of x. Now I will explain how we can find the value of g of f. Suppose f of x equal to sin x and g of x equal to x cube. Question is find g of f and f of g. This type of question you can expect for 1 mark. Where question is find g of f, it means you have to find g of f of x. F of g means you have to find f of g of x. So first we'll find g of f of x. G of f is a function. G of f of x means g of f of x. So first we'll write its definition. That is g of f of x. That is equal to g of, what is value of f of x? F of x equal to sin x you will get. Right. Now we want to find g of sin x. G of sin x. For finding g of sin x, you have to use this definition. This is its general formula. G of x equal to x cube. G of 10 will be 10 cube. Therefore, in place of x, we have sin x. Therefore, g of sin x will be, here I have to substitute sin x. It will be equal to sin x. In place of x, sin x. So, right hand side is x cube. So, this will be sin x whole cube. That is sin cube x. Sin x whole cube is same as sin cube x. So, g of f of x equal to sin cube x we are getting. Now, you have to find f of g means f of g of x you have to find. The same way, f of g of x is equal to f of g of x. That is its definition. So first we'll find f of, what is g of x? G of x equal to x cube. So now we want to find f of x cube. For finding f of x cube, you have to use definition f of x equal to sin x. F of x sin x. In place of x, we have to substitute x cube. So right hand side also, in place of x, we have to substitute x cube. So answer will be sin x cube. So f of g of x equal to sin x cube we are getting, and g of f of x equal to sin cube x we are getting. Okay. Now, using the concept of composition of function, we can do some questions. After that, we will find inverse. Okay. So, this one was a 1 mark question for board examination. So, let f of x equal to mod x. G of x equal to greatest integer less than or equal to x. Question is, find g of f of minus 5 by 2. So, just you have to use definition. G of f of minus 5 by 2. This will be equal to g of f of minus 5 by 2 by definition. Now we want to find f of minus 5 by 2 first. For that you have to use definition. F of x mod x. So f of minus 5 by 2 will be mod minus 5 by 2. Right. Now what is mod minus 5 by 2? It is equal to 5 by 2. So you get g of 5 by 2 will get. G of 5 by 2 means g of 2.5. Now you have to use definition of g of x. G of x greatest integer of x. So g of 2.5 will be greatest integer of 2.5. The greatest integer of 2.5 is 2. Now consider second question. Let f from a set 2, 3, 4, 5 to another set 3, 4, 5, 9, and g from 3, 4, 5, 9 to 7, 11, 15 be functions defined as f of 2, 3, means 2 is related to 3, f of 3, 4, 3 related to 4, f of 4 equal to f of 5 equal to 5. That means image of 4 and 5 are same, that is equal to 5, and g of 3 equal to g of 4 equal to 7. Image of 3 and 4 is equal to 7. Then g of 5, g of 7 equal to 11. Find g of f. So first we can take the set as A. Suppose A equal to 2, 3, 4, 5 and B equal to 3, 4, 5, 9. Okay. And C equal to the third set, that is 7, 11, 15. So then we can rewrite this one as f is a function from A to B. We'll get right. And G is a function from, these two are same set. So G is a function from B to C. That means G of f. You have to find G of f. So G of f, f from A to B and G from B to C. That means G of f is a function from A to C. So for finding value of G of f, you have to take elements of A. So domain of G of f is A and codomain of G of f is C. So we will find image of first element of A. So image of first element of A is 2. So G of f of 2 we have to find. That is equal to G of f of 2. That definition we can use. It is equal to G of, what is f of 2? F of 2 is given as 3. So G of 3 and G of 3 equal to 7. So image of 2 is 7 under the function G of f. Now you have to find image of second element of A, that is G of f of 3. G of f of 3 equal to G of f of 3. That is G of f of 3 equal to 4 you are getting. So 4 and G of 4, what is G of 4? G of 4 equal to 7. So image of 3 is equal to 7 under the function G of f. Now you have to find image of fourth value of A, that is 4. G of f of 4 we want to find. That is G of f of 4. G of f of 4. What is f of 4? F of 4 equal to 5. So we have to find G of 5 and G of 5 is equal to 11. Now last value, that is G of f of 5. Image of 5 you have to find. G of f of 5 is equal to G of f of 5. Now what is f of 5? F of 5 equal to 5. So you have to find G of 5. G of 5 equal to 11. Now consider third question. It's actually a result. Show that if f from A to B and g from B to C are 1, 1 function, then g of f from A to C is also 1, 1. If f and g are 1, 1, we want to show that g of f is also 1, 1. Since f is 1, 1, f of x1 equal to f of x2, then you will get x1 equal to x2. Since g from B to C is 1, 1, g of x1 equal to g of x2, you will get x1 equal to x2. Otherwise, g of y1 equal to g of y2 implies y1 equal to y2 will get. So, you have to show that g of f is 1, 1 from A to C. So, 1, 1, at x1, x2, you have to take domain of g of f, that is A, and your function is g of f. So, g of f of x1 is equal to g of f of x2, and you have to show that x1 equal to x2. Then we can say that g of f is 1, 1. G of f is a function. So next, first you have to use definition. This one is g of f of x1 is equal to g of f of x2. Now f of x1 and f of x2 are two elements and g is a function. Since g is a function, g of x1 equal to g of x2 implies x1 equal to x2. So in place of x1 and x2 we have f of x1 and f of x2. So since g is 1, 1, this implies f of x1 equal to f of x2. Reason g is 1, 1. Okay. Now since f is 1, 1, f of x1 equal to f of x2 implies x1 equal to x2. Since f is 1, 1, that means g of f of x1 equal to g of f of x2, then we are getting x1 equal to x2. Therefore, g of f is a 1, 1 function if f and g are 1, 1. One important result. Okay. Now consider our fourth question. This is also a result. Show that f from A to B and g from B to C are onto, then g of f from A to C is also onto. Given that f and g are onto functions, we want to show that g of f from A to C is also onto. For that, if we take any element of C, if we are able to find one x belongs to A, such that image of that x equal to that element, then we can say that g of f is onto. For that, you have to use these two conditions, given that f and g are onto. So suppose element of A, we can take element of A as x, element of B as y, and element of C as z. Now, since f is onto, f from A to B is onto, that means for any element in B, we can find one x here. So that means for every y belongs to B, there exists A, x belongs to A, such that f of x equal to y will get. Same way, since g is onto, g from B to C is onto, for any z belongs to C, there exists. For any z belongs to C, there exists A, y belongs to A, y belongs to B, such that g of y equal to z will get. F from A to B is onto, for any y belongs to B, there exists one x belongs to A, such that f of x equal to y will get. Since G from B to C is onto, for any set belongs to C, there exists a Y belongs to B, such that G of Y equal to Z. Now we want to show that G of F from A to C is onto. For that, I'll write the proof here. Let Z belongs to C. Then we want to show that there exists a X belongs to A, such that G of F of X equal to Z. Now, just find G of F of X. So, what is G of F of X? By definition, this is equal to G of F of X, right? That is, G of F of X means F of X equal to Y. So, we'll get G of Y. Now, what is G of Y? G of Y equal to Z. That means for any set belongs to C, there exists a X belongs to A, such that G of F of X equal to Z. Therefore, G of F is onto. So, if F from A to B and G from B to C are onto, then G of F from A to C is also onto. It's a result, but it is important. Okay. Now consider one result. Using this result, we will find F inverse. It is given like this. Let F from A to B be a bijective function defined as F of X equal to Y and G be inverse of F. Then G of F equal to IA means identity function on A. And F of G equal to IB means identity function on B. Function on A means A to A. That means you have to show that G of F is an identity function from A to A. And you have to show that F of G is an identity function from B to B. So, what about identity function? A function F is said to be identity if F of X equal to X. Right. Here you have to show that G of F is identity function. That means you have to show that G of F of X equal to X. G of F of 1 equal to 1. Like that you have to get. So, first we will verify whether G of F is a function from A to A. So, for that, just draw a set A, a set B. Instead of C, I am writing A. So, F is a function from A to B and G is a function from B to A. Now, it is given that F of X equal to Y and G is F inverse of F. So, how we will represent G? F of X equal to Y, then X equal to F inverse of Y. Since F inverse equal to G, we will write X equal to G of Y. Right? F of X equal to Y, then X equal to F inverse of Y. Here, given that F inverse is G. So, F of X equal to Y implies X equal to G of Y. Like that you have to take. So, X element of A, then F of X will be element of B. Now, G is a function from B to A and element of B is F of X or F of X is element of B. So, image of F of X will be in A. So, G of F of X, right? G of F of X. So, G of F is a function. G of F is a function from A to A. Now, we want to show that G of F of X equal to X. For that, let's find G of F of X equal to, use definition, so we get G of F of X. That is G of, what is F of X? F of X equal to Y. So now you have to find G of Y. What is G of Y? G of Y equal to X. So G of Y equal to X, which implies G of F of X equal to X for all X belongs to A. That means G of F is an identity function on A because G of F is function from A to A. So we can denote it as IA. Okay. Now we want to show that F of G is an identity function from B to B. IB is given. You have to draw B first. B, A, again B. So G is a function from B to A and F is a function from A to B. Consider Y as element of B. Then image of Y will be in A. So element of image of Y we can write as G of Y because G is a function from B to A. Now F is a function from A to B and G of Y is element of A. Therefore, image of G of Y under the function F will be in B. That is F of G of Y. F of G of Y means F of G of Y means F of G. F of G is a function from B to B. So it is clear that F of G is a function from B to B and G of F is a function from A to A. So now we want to show that F of G of Y is equal to Y. For that, just use definition. That is F of G of Y. F of what is G of Y? G of Y equal to X. F of X. F of X equal to Y. That means we are getting F of G of Y is equal to Y. For all Y belongs to B. That means F of G is an identity function on the set B. So conclusion is this one. If F is a bijective function from A to B defined as F of X equal to Y and G be inverse of F, then G of F of X equal to X and F of G of Y equal to Y. That means G of F is an identity function on A and F of G is an identity function on B. So we will reach one conclusion is that for any function F from A to B, for any function F from A to B, if there exists a function G from B to A such that G of F equal to IA and F of G equal to IB, then F is invertible and F inverse equal to G. For showing a function is invertible, you can prove by this method also. That means you have to find one G satisfying the condition G of F equal to IA. That means G of F is equal to X and F of G of Y equal to Y. Then we can say that F is invertible. So we have two methods for finding invertible. That is, first one is 1-1-on-2 method and second one is by using composition. But 1-1-on-2 method is real method. If question is show that function is invertible, then you can use any of the methods. But if question is verify whether F is invertible, then you have to go for 1-1-on-2 method because by using this method you cannot verify. Okay. If question is show that, then you can use this method. Now consider one question. Let F from R to R be a function defined as F of X equal to 7x plus 9. Show that F is invertible and find F inverse. Question is show that F is invertible. So you can use any one of the two methods. In this question, I will use composition method. So how we can use composition method? We want to find one G satisfying the condition G of F of X equal to X, F of G of Y equal to Y. Then we can say that F is invertible. Okay. So given that F of X equal to 7x plus 9 and F of X equal to Y, we will start from this step. So F of X means 7x plus 9 equal to Y. So what is value of X? It is Y minus 9 by 7. Now we will define a function. Let G from R to R be a function defined as G of Y equal to Y minus 9 by 7 and defining a function from R to R means codomain to domain such that G of Y equal to Y minus 9 by 7 at the same value of X. Then what about G of F of X? G of F of X equal to G of F of X. That is G of, what is value of F of X? 7x plus 9. Now we want to find g of 7x plus 9. For that you have to use g of y. This is standard formula. G of y equal to y minus 9 by 7. So in place of y, you have to substitute 7x plus 9. So what you will get? G of y equal to y minus 9 by 7. Therefore, g of 7x plus 9 this will be equal to 7x plus 9. In place of y, this value I substitute minus 9 by 7. That means plus 9 minus 9 get cancelled. 7x by 7 equal to x. So g of f of x equal to x we are getting. Now we want to find f of g of y. F of g of y should be equal to y. So we will use definition f of g of y. F of g of y means f of g of y equal to y minus 9 by 7. That is equal to, now we have to use f of x equals 7x plus 9. So in place of x, we have to substitute y minus 9 by 7. F of y minus 9 by 7 you have to find. So answer will be 7 into y minus 9 by 7 plus 9. Right. So minus 7 plus 7 can cancel. Y minus 9 plus 9. So this will be equal to y. So f of g of y equal to y and g of f of x equal to x. That means f is invertible and f inverse equal to g. So at last we can conclude like this. F inverse equal to g. Means f inverse of y equal to g of y. What is g of y? G of y equal to y minus 9 by 7. F inverse of x will be g of x like that. F inverse of z will be g of z. So you can use this method also. For doing this method, first you have to take f of x equal to y. Then you have to find x in terms of y. After that you have to define a function g from codomain to domain or range to domain defined as g of y equal to x. X equal to y minus 9 by 7. Then you have to show that g of f of x equal to x. F of g of y equal to y. So if a function satisfies these two conditions, then we can say that g is inverse of f or f is invertible. Now consider one more question finding inverse by using composition method. Okay. So show that f from a to b defined by f of x equal to 7x plus 4 by 5x minus 3 is invertible. And you have to find f inverse where a equal to r minus 3 by 5 and b equal to r minus 7 by 5. Now, first you have to find g. For that you have to take f of x equal to y. So f of x means 7x plus 4 by 5x minus 3 equal to y. Now you have to find x in terms of 5. For that you have to cross multiply. So you get 7x minus plus 4 equal to 5xy minus 3y. Right. Take all terms containing x to one side. So 7x minus 5xy will get is equal to minus 4 minus 3y. Right. So take x as common. Remaining term will be 7 minus 5y is equal to minus of 4 plus 3y will get. So what is value of x? Minus of 4 plus 3y by 7 minus 5y. That is 4 plus 3y by 5y minus 7. Now we can multiply numerator and denominator with minus 1. So x equal to 4 plus 3y by 5y minus 7. So y should not be 7 by 5. Right. If y equals 7 by 5, x is not defined. That is why range equal to r minus 7 by 5. Now you have to define one function. Let g be a function from b to a defined as g of y equal to x. What is x? X equal to 4 plus 3y by 5y minus 7. Now we want to show that g of f of x equal to x and f of g of y equal to y. So for that, g of f of x you have to find. Use definition, that is g of f of x will be equal to g of, what is f of x? F of x equal to 7x plus 4 by 5x minus 3. Now we want to find g of 7x plus 4 by 5x minus 3. For that you have to use this definition, g of y. In place of y, you have to substitute this value. So you'll get 4 plus 3 into y. Y means 7x plus 4 by 5x minus 3 whole divided by 5 into y. Y equal to 7x plus 4 by 5x minus 3 will get. Then minus 7. Right. This will have to cross multiply. So we'll get 4 into 5x minus 3 plus 3 into 7x plus 4 by denominator is 5x minus 3 whole divided by, here also you have to cross multiply, 5 into 7x plus 4 minus 7 into 5x minus 3 whole divided by denominator. So you can cancel common denominator. Numerator you have to expand. So you will get 20x minus 12 plus 21x plus 12 whole divided by 35x plus 20 minus 35x plus 21. You can cancel common term, minus 12 plus 12, 20x plus 21x, 41x you will get. Here plus 35 minus 35 you can cancel, 20 plus 21, 41. So we are getting x. That means g of f of x equal to x you will get. Now you have to show that f of g of y equal to y. F of g of y. By definition, this is equal to f of g of y, that is f of g of y. G of y means 4 plus 3y by 5y minus 7. This value you have to substitute in f of x, f of value. F of x means, this is the formula. In place of x, you have to substitute this value. So answer will be 7 into x. X means 4 plus 3y by 5y minus 7 plus 4 whole divided by 5 into x. X means 4 plus 3y by 5y minus 7 minus 3. This you have to simplify. So this will be equal to 7 into 4 plus 3y plus 4 into 5y minus 7. We are finding LCM by 5y minus 7 whole divided by, here also you have to find LCM. So you will get 5 into 4 plus 3y minus 3 into 5y minus 7 whole divided by 5y minus 7. So you can cancel 5y minus 7. Remaining I will write here. So numerator plus 21y plus 10dy minus 28. And denominator also you can expand. So you will get 20 plus 15y minus 15y plus 21. We can cancel plus 28 minus 28 plus 15 minus 15 remaining 21y plus 20y 41y will get denominator 20 plus 21 again 41. So answer equal to y. That means you are getting f of g of y equal to y and g of f of x equal to x. Therefore f is invertible and f inverse equal to g. F is invertible and f inverse equal to g. So that means f inverse of y equal to g of y. What was the value of g of y? G of y equal to 4 plus 3y by 5y minus 7. Sometimes you can expect question find f inverse of 1. So in place of y you have to substitute 1. So in this way we can prove that a function is invertible. So today we can conclude this section. In the next section we can do more problems.